So it is. So that is known as long-sightedness. You can see far, but you can't see close range. Short-sighted, you can see close, but you can't see long range. So when you are talking about long-sightedness, it can be corrected using what? Either you call it a convex lens or a converging lens. Now, if you do not see concave, there might be converging lens. Here, if you do not see concave, they might change it to what? Diverging lens. So know it that be it diverging lens or concave lens, we are referring to what? Similar thing here. Am I communicating? Yes. Good. So we've looked at question number 2. Let's look at question number 3. We're moving on with it that way, beginning, picking the key points from each of these questions, ranging from different topics. At the end of your 2 hours, you should be proud of yourself. Okay, I clean the board. Those of you coming late, just look at your colleague's book and know how far we've gone. Question 3 here. Last year's question here. Good. An object of height 4 centimeter 4 cm is placed, and this marker is writing, in front of a cuboid pinhole camera, of size 6 cm. The full stop. If the image formed is 2 centimeter high, how far? Here is the question. How far is the object? Please, Vic, you rephrase this for me. From the pinhole. H-O-L-E, please rephrase this for me. Let me pass it. How far? Okay. Is the pin? Okay, how far is the object from the pinhole? How far is the object from the pinhole? Are we true? Yeah, we'll look at it. Okay. Be fast. Welcome. We have 2 formulas with respect to magnification. We are talking about magnification. Most of us, we can illustrate that with the help of microscope. We are looking at the size of an object, how big or how small an object is. So here we represent it with capital M here as our magnification. I told you we have the 2 formulas here. We have the next one as here, magnification. The first one, we'll talk about the length of the camera to the distance, that is the ratio of this to this, distance of the object. The second one here for magnification, we call it either the image height or the image distance to the object height or the object distance. We have this 2 here for magnification. Now let's see how we'll be able to relate this formulae with the question under consideration. From here, you should be able to do something. What are they asking us to look for from that question?
The image.
Eh?
Sorry, the object distance.
Okay. If Mr. Victor is here and I'm standing in front of a mirror, that means if I left home, I looked at myself in a mirror. Me standing here outside, I am the object. What is formed, what I'm seeing, my image I'm seeing in is called the image. What I'm seeing inside the mirror is the image. While me here, the physical person, I am the object. Now, we are asked to look for what from that question? What are we asked to solve for? Object distance. So look at me, we'll just do two things, I'll do this. From the question, they gave us the image height. Right?
Yes.
Good. They gave us the object height.
Yes.
So I can use this formula here to get magnification. When you get your magnification, you substitute your magnification here. You know your length of camera. They gave us 6 centimeters there. Yes. Then you can use it to get your distance of object, which is the object distance. Straightforward. From the question, you know your image height. You know your object height. They gave it to us there. It's like here is 2. Image height is 2 centimeters. Object height is 4 centimeters from the question. So it's going to be 2/4. You get your magnification, 0.5. You substitute, bring it here. Since we are looking for here, 0.5 is equals to 6 because they gave us there length of camera 6 divided by this. We are now solving for this. I finished explaining. You should be able to do that. Magnification is equals to 2, which happens to be the image height, divided by 4, that happens to be the object distance. That gives us 0.5 as your magnification. You substitute here. You substitute the 0.5 here. So it will now be 0.5 being your magnification is equals to length of camera, which happens to be 6 from the question, divided by x, which is the distance of the object. You can solve for x. Which is true. How many of us that should give us, is it 12 or thereabout? I don't know. But I suspect it should be 12 centimeters. Remember, we are talking about distance here.
12 centimeters.
You got 12? That is the answer. I'm not expecting anybody to ask me how we arrive at 12 after this self-explanatory stuff I did here. It's very, very simple. You are not converting. You are not looking for any unit or any value on your own. All values are already there. They've given it to us. They gave you your image height. They gave you your object height. Use it to get magnification. Substitute the value for magnification up here. You already know your length of camera. They gave it to us as 6 from the question. Magnification, which is 0.5 that we have gotten from here. So it will now be 0.5, which is the magnification, is equals to length of camera. They give it to us as 6 all over distance, image, object distance, which we are looking for. Let's call it x. This is over 1. From here, you can cross multiply. Solve for x. You have 12 there. If you don't use that method, you can just use, you can combine these two formulas here to give you 1. You can combine it and substitute directly. This is it here. We still have same answer. I decided to do the first one, then we'll come back here. Magnification is equals to image height. You can either call it height or distance. So now when you see a question that is talking about image height, you say, Mr. Victor, which one be height? Nah, distance, now you teach us. So it's either image height or image distance. All over object height is equals to length of camera to what? The object distance. Look at it here. This is a combined formula. Instead of splitting it, then you have to substitute the value you got from here into this. You can use it as a combined formula. But sometimes they might only give you this like this to ask you to look for magnification. Sometimes they'll give you magnification, give you image height, you'll be asked to look for object height. So you have nothing to do this side. Sometimes they'll give you length, object distance, and you'll be asked to look for magnification. As such, you have nothing to do here. So you have to look at the parameters given to you. If the parameters comprises of all these parameters, you can combine the both formulas and use it as one. So here now, look at it here. My magnification. Here, let me try something. What are we going to do here? From here, what are we going to do? Of what?
So we see the values into the equation.
Of magnification. Yes. So that is to mean, however it goes, you must use one of these formulae to get your magnification first. Because the question didn't give us magnification. Except in a scenario, in a situation, in a condition in which you are giving your magnification, you can just substitute directly. But in this case, you are not giving. So how can we be looking for two unknown simultaneously? It's very, very difficult. So you see that we must use this one to get this. But since we've done that already and we've known our magnification, let's look at it this way. Let's assume they gave us our magnification. We got what as magnification? 0.5. Is equals to what is the image height? 2 all over this 4 is equals to, look at what I'm doing here. Yes, okay, 6 all over x. Here I can just abandon this as well because that is not what I'm looking for. This is what I'm looking for. So forget about magnification. That is it. So it means you can actually solve without going to look for your magnification first because it is irrelevant. That is not what you are asked to solve for. The parameters you are asked to solve for, you've gotten it here. So from here, you can have that answer. You have something like this, all you need to do cross multiply. 2 times x will give us 2x. Is equals to 6 times 4 will give us what? 24. You are looking for x divided by the coefficient. We have this, our x is going to give us 12. So however it goes, any method you want to use, please and please. The challenge there is, remember the formulae. You see, since we are having object, height, this, you might likely mix it up. Some persons will do object before height. You put object height before image here. Object height divided by image height. That is not the formula. It is the image that is coming before the object. And don't mix it up. It is the length of the camera that is coming before the object distance, not the other way around. So once you begin to rotate your parameters, you see yourself having different answers. Some of you may have 1 over 12, and you see 1 over 12 as an option. Some of you have 24 based on the way you changed or you interchanged your parameters. Let's move on. Okay, so that is question 3 for today. Let me take your knowledge down to escape velocity. Escape velocity, gravitational constant, mass of planet Earth. Yes. Okay. If the radius of the Earth is 6.4 times 10 raised to power 6 meters, that is our radius, that is for small letter R there. If the radius of the Earth is 6.4 times 10 raised to power 6 meters, comma, the escape velocity of a satellite, look at it, escape velocity, you don't know, the escape velocity of a satellite from the Earth is, the only parameter again they gave to us is g here, as usual, 10 meters per second square. If the radius of the Earth is 6.4 times 10 raised to power 6 meters, the escape velocity of a satellite from the Earth is how many of us can attempt that question? Good. You can attempt that question? Okay. Those of us that can attempt the question, let's give it a try. If you can attempt it. First, that will not waste time because we have a lot to do. Now we have two different formulas for escape velocity. We are going to try it out with both. You just have one, you need to know certain constants. Here, the first formula here I'm going to give to you, which I expect each and every one of you to do this, is very, very simple. Escape velocity here, call it this, is equals to the square root of 2g what? Call it this way here, where your g is equals to your acceleration due to gravity that happens to be 10 meters per second square, and your arrow here represents the radius, which from the question they've given us the radius to be what? 6.4 here times 10 raised to power 6 meters. All you need to do, substitute. So it's going to be 2 times 10 times 6.4 times 10 raised to power 6. Then square both sides. So I'm looking for velocity, not velocity square. So from here you can do that. What is the final answer there? Those of you just coming, I told you guys last week that we will be looking at continuation of light down to sound, mirror, concave, convex in physics. I'll be looking at organic chemistry in chemistry. I decided to do something different because most of us, or some of us, all are taking JAMB mock. So since what we've been doing is a series, I don't want them to miss out because why they are not here is justifiable. Hence, I decided to pick questions from different topics and use it to learn. And I believe that at the end of 2 hours, we should be able to also cover a wide range of topics instead of concentrating on one topic. No knowledge is a waste. This is even preferable than looking at one topic. And I believe this happens to be the 4th question we are looking at. So please do well to look at what and what we've done. Even if you can't get the explanation since you came late, endeavor to pen it down and do your own reading. Having said that, who is true with this? Escape velocity. What is the answer?
1.13 times 10.
1.13. Who is having similar answer? 1.13.
Times 10 raised to power 4.
Okay. At least that 1.13 should give others insight. Who is having 1 point something? Or who is having a different answer? Okay, some of you, because he said his own in a standard form. In standard form. This is simple. All you need to do is just to substitute the values here into that expression. Straightforward question. Substitute the values given to you into that expression. Okay, let's look at the second formula. We are going to try it out, the second formula. Let's see if we arrive at similar answer or a different answer. Those of us that are true with this signify. What is happening? I'm true with this, signify. That is the only way we can compare. I want us to use this method, then we'll use the other method. Let's see if we arrive at similar answer. So since we are not done with this, how then do we compare? This is straightforward now. Multiply these. Escape velocity here is going to give us 2 here times our g is 10 times our radius, they gave it to us from the question, 6.4 times 10 raised to power 6. That's all here. This is what I'm expecting you to do.
1.1131.
And at the end, escape velocity, I believe you should have the square root of 28,000. 1, 2, 3, or is it 28 million? If you do this, you're having this. To the square root of this.
1131.
Huh?
1131.
313.7. Okay, 128. Yeah, when you do this. So when you square this, you should be able to have something similar to that. That's all. Straightforward question. So the only challenge here is you knowing the formula for escape velocity. So I believe with respect to this class, don't forget this formula. Forget that one. Look at this again. This is another formula for this. Escape velocity here is equals to the root of what? Yes, who knows the formula?
The second one.
Yes.
2GM over R.
Good. 2GM all over R here. Where your M here is mass, but here this G here is not our gravity here. This G here is what? The what? Gravitational constant. That is what this G is. Why here it represents the mass of the earth. Why here represent the radius. So from here, the only thing you need to know here is, you don't know this. We also have a constant for this. What is the constant? 6.00 times 10 raised to the power 24. That is the constant for the mass of the earth. So you need to know that. That is the challenge with this. But this one, you don't need to memorize anything. Once you know, you already know your G, which is your small g. Let me turn it to a small g here. You already know your what? Your radius from the question. But this other one, this one was not given to us from the question. It is me or you that need to know that a constant for what? The mass of what? The earth is what? 6.00 times 10 raised to the power 24. So having known this, having known your what? Your gravitational constant, you should be able to do that. What is your gravitational constant?
6.0
Times. Good. Good. Most of you are saying a different thing. Good. Okay. What is the constant value for G? 6.67 times 10 raised to the power. Good. Minus what? 11. So not 9. So that should be what you should use there. Try it out. We should be able to have similar answer. I've given you here, our G here is equals to 6.67 here times 10 raised to the power minus 11 here. Our M here, which is the mass, is equals to 6.00 times 10 raised to the power 24. From the question, they gave us our radius as what? They gave us radius as what from the question? 6.4 times 6 here. That's all. So all you need to do, substitute into this here. That's all. You should be able to arrive at similar answer. So it's going to be the square root of 2 times 6.67 times 10 raised to the power minus 11 times 6.0 times 10 raised to the power what? 24, or divide by 6.4 times 10 raised to the power 6, which happens to be the radius given to us from the question. So irrespective of the formula you use, you should be able to arrive at similar answer. Let's do that and confirm our answer before moving to the next question. Escape velocity, formula 1. Escape velocity, formula 2. So use any formula to arrive at your answer. While doing that, we looked at question under lenses, we looked at question under electromagnetic field, we looked at questions that has to do with the power of lens. Now let me move your attention to electricity. I'm going to move your attention now to electricity. So you see, we doing this, we are gaining and learning from different angles. Electricity. Are we through so that I can clean the board? This shouldn't eat your time. You are even with calculator. I just need one person that will give me confirmation that the answer is similar. What? Titi. Titi. None of you. come across this question, this is how you waste time before you attempt this one question. Okay, got the parameters. You can't do that here in class. And battle with it. JAMB that you not even have scientific calculator. And here you're even having scientific calculator. And it's taking you long. I told you guys, we won't follow you to the exam hall. Ours is to teach you. If your own problem, you can't convert this little mathematical this, you can't express it. That is a problem based known to you. There is no two ways about it. You can't do magic there. As we teach you, we'll give you the formula. I'm saying how to apply the formulas. But you don't know how to apply the calculator to get your answer on your own. Okay. 4 cells. Leave that, do it at home. Can't wait for you forever. 4 cells. Four cells each of electromotive force 1.5 volt and internal resistance of 4 ohms are connected in parallel. Are connected in parallel. What is, here comes the question, what is the effective EMF, electromotive force, and internal resistance? What is the effective EMF and internal resistance of the combination? There's a question. They gave us option A here, 6.0 volts and 16 volts, 16 ohms rather. That means one is representing the EMF and the second option is representing the internal resistance. Option B here, they gave us 6.0 volts as the EMF and they gave us 1 ohms as the what? Internal resistance. Option C here, we're giving 1.5 volt as the electromotive force and they gave us 4 ohms as the internal resistance. And the final option here, we are having 1.5 volts and 1 ohms as the internal resistance. 4 cells each of EMF 1.5 volts and internal resistance of 4 ohms are connected in parallel. Take note of this word, they are connected in parallel. You know, a resistor can either be connected in series or in parallel. And in this case, they've given us what? 4 resistance and what? How is it called? EMF, all connected in parallel. What are we to do? You are asked to look for the value of the internal resistance and EMF respectively. What do we do? Okay, don't waste our time. Most of you are looking at me. Let's start with our EMF. So we'll do what is known as elimination method. They are connected in what? Good. Once your resistors are connected in parallel, the overall, the effective EMF is as good as saying the EMF of 1. Let's say anything. So forget about this. 4 cells each of EMF 1.5. Yes, there are 4 cells and they are having EMF. 1 is 1.5, second one is 1.5, third one. For you to calculate the effective EMF, since they are connected, not just when you see in series, since they are connected, that was why I said underline this word. Since they are connected in what? Parallel. The effective EMF is as good as the EMF of 1. So what is going to be the effective EMF? 1.5. As such, you have to eliminate A, you have to eliminate B, because it's only C and D that is having your EMF as option 1.5 and 1.5. The next option now is to solve for our internal resistance, which is as good as solving for your resistance. They are connected in parallel and they are 4. That means 1 over 4 plus 1 over 4 plus 1 over 4 plus 1 over 4. Do that, you should be able to have 1. Look at it now. They're giving the ohms as 4, and they are 4, and they are connected in parallel. 1 over 4, 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. Assuming they were connected in series, it will be what? R1 plus R2 plus R3 plus R4, and that will give us 4 times 4, 16. But since in this case they are connected in parallel, you have to look for the inverse. 1 over R1, which is 1 over 4 plus 1 over R2, still 1 over 4 plus 1 over R3, still 1 over 4 plus 1 over R4, which is still R4, which is still 1 over 4. So if you do this, eventually you have 1 as the answer. So that gives us option D. Some of you are still looking at me to prove how I got 1 there. One over 4 plus 1 over R2 plus 1 all over R3 plus 1 all over R4. The LCM here is giving me 4. Look at there. 4 and 4, 1. 1 times 1, 1. Plus 4 and 4, 1. 1 times 1, 1. Plus 4 and 4, 1. 1 times 1, 1. Plus 4 and 4, 1. 1 times 1, 1. Everything here gives me 4 all over 4 equals to 1. So